welcome to another episode. So today we're going to be doing the 2021 Fall AMC 12B number 21. What is the average number of pairs of consecutive integers in a randomly selected subset of 5 distinct integers chosen from the set from 1 to 30 positive integers? This is an example which has 2 pairs of consecutive integers because 7 and 18 and 18 and 19 are 2 different pair, and we don't have any other pair. So this one is definitely solvable by just bashing out all the possible cases that when the first two are consecutive or the second and third one consecutive or so on. And this will probably take a lot of time, and this is doable in Amy. However, it's definitely not going to be a time sink in AMC problems. So in order to do this, we have to understand a concept called linearity of expectation, which is actually a pretty well seen concept in doing the expected value problems. So what is the average number of pair of consecutive integers? This is basically asking what is the expected value of the number of pairs of consecutive integers when a randomly selected 5 integer subset is chosen from all the possible such subsets. So linearity of expectation tells us that if x of 1, x of 2, dot dot dot, and x of n are random variables, they do not, keep in mind, they do not have to be independent. They can be dependent. So one of the examples is saying that, so let's say, how many find the expected value. So let's say find the expected value of the number of heads right? So we see that all the events, which is the flipping of head or tail, are essentially independent from each other. Right? But however, let's say find the expected value of the number of substrings which had a head and a tail, right? Then each of them will be 1/2 from the previous one. And however, this one's definitely dependent, because if you have a head in this flip, then the next flip you must have a tail, and this is actually dependent from the previous probability. So then let E of n denote the expected value, then E of x of 1 plus, so I'm probably going to use bracket since this is more of an official way, then E of x of 1 plus x of 2 plus dot 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 plus x of n, that is essentially equal to, let me just write it in a sigma notation, from n is equal to 1 to n of E bracket E of x of k. So this is essentially the definition of expected value. All right, so now how can we use this in our problem? Well, by the way, this one is just a shortcut of expected value. So for example, let me just give an example. So let's say I want to find the expected value of the number showed up when rolling a 6-sided dice, right? Of the sum of numbers when rolling a 6-sided dice twice. So let's say you want to find this thing. So a typical way is just going to find the number of cases that a sum occurred times the sum, and then sum it up from 1 to 12. An entire thing divide by 6 times 6. And that is just our expected value. However, by using the linearity of expectation, then we can just say it's basically, right, the expected value of rolling 1 dice and then multiply by 2, since they're like the same. So this will just give me a 7/2 times 2, which is 7. So this is how this can be a shortcut and save a lot of steps. So now how can we use this in our problem? So now this motivates us to write the 5 numbers as A. This motivates us to write the 5 numbers as A, B minus plus A, C minus B plus B, D minus C plus C, E minus D plus D. Well, one can probably say that this one kind of looks really obvious, right? Since we're adding one number and then subtract a number, then this one does not really change. However, now we can just extract the 5 numbers called A, B minus A, C minus B, D minus C, and E minus D. So this is basically so A is just the first number of the set, which is the smallest, since this is like sorted from least to the greatest. And B minus A is basically the difference between the first number and the second number, and so on. So now let's look at a set, for example. So let's just look at this. So this we have 1, the difference of 16, 1, 1, and 11. So you have 1 plus 16. So we have 1 plus 16 plus 1 plus 1 plus 11, which is 30. So this basically shows that if the greatest of the 5 numbers is 30, which is the maximum, then the sum of these 5 numbers must be 30. So in other words, the 5 numbers, the sum must be less than 30, which is a positive integer, right? So now how are we going to do this? So the sum of 5 positive integers must be less than or equal to 30. Well, 2 numbers A and B are consecutive. What is the condition that makes them consecutive? When their difference is equal to 1, right? Therefore, if B minus A is equal to 1, then B and A are basically consecutive. So this seems to be pretty straightforward, right? So now we basically just want to find the expected value of the number of ones in these 4 numbers. So this can be just used by linearity of expectation, which x1 is just B minus A, x2 is C minus B, x3 is D minus C, and x4 is E minus D. So now, if B minus A is equal to 1, what numbers can the other 4 be? The sum of the other 4 must be less than or equal to 29, right? Must be less than or equal to 29. Also, now how can we find the number of cases when four numbers is equal less than or equal to 29? So now we basically just have a1, let's just say a, b, and c, and d, right? Well, a plus, well, let's just call it four numbers, right? Like a plus b plus c plus d is equal to 29, which of a, b, c, and d are greater than or equal to 1. So in other words, greater than 0. So now, if we make 29 to be actually 29 of the 29 lines, right? Which we can just make it to be 29 balls. Well, and then if we draw 3 dividers to it, we see we're going to get 4 piles, and each of the ball represents 1. So we get 4 piles, which represents a plus b plus c plus d is equal to 29, and they are actually distinguishable. So this is actually just called stars and bars, which we have 29 lines, and then since each of them is 1, then therefore we only have 29 minus 1, which is 28, which is 28 places to put dividers in, right? Since we have a divider from between ball 1, ball and ball 2, and so on until ball 29 and ball 30. Well, and then we subtract, right? No, ball 28 and ball 29, which we have 28 minus 1 plus 1, which is 28 such places to divide. However, we wanted this to be less than or equal to 9, right? So in order to be less than or equal to 9, then we're just going to add all the possible cases. So this, from my previous explanation, which gives 28 choose 3 plus 27 choose 3 plus dot 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 plus 3 choose 3. Well, now when we look at the Pascal's triangle, we can actually find a pretty amazing pattern, which is this sum is actually going to be equal to 29 choose 4 by using the ball and urns. By using the ball and urns, which states that n choose k plus dot 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 plus k plus 1 choose k plus k choose k, and that is actually equal to n plus 1 choose k plus 1. So essentially we're just looking at this identity, which can be actually proved by looking at the Pascal triangle and try to manipulate the combination identities. Also, now we have that if b minus a is equal to 1, then the number of possible cases for all the numbers are 29 choose 4, and by linearity. Well, and then the probability is just 29 choose 4 choose 4, and then what is the numerator? So the total numerator is just when we're trying to distribute the 5 numbers be less than or equal to 30, right? Or it's just actually 30 choose 5, since we're just choosing 5 distinct integers from the set. So we can see that this expression, so this expression 29 choose 4 over 30 choose 5 is just the probability that one of these b minus a, c minus b, d minus c, and e minus d is equal to 1, right? But then by the linearity of expectation, we actually have to add it 4 times when we account for the other 3, which is C minus B, D minus C, and E minus D. So therefore, we have to multiply this entire thing by 4, right? Well, so this is actually just our desired expected value of the number of pairs of consecutive integers in a random selected subset. So when we compute this one, we can see that 29 times 28 times 27 times 26 automatically canceled, which gives us 5/30. But then we have to multiply it by 4, which is equal to 20/30, which is equal to 2/3. Right. So this is essentially our probability that we desire. And thank you for watching. Hope you enjoyed this content, and if you like, don't forget to subscribe. And see you in my next video, which I'll continue to explain the 2021 AME 1 solutions. Bye.